Okay, so this is assignment 5. In this assignment, we had to use the code from the tutorial and change the generator and discriminator from using CNN architecture to using, or change it from using MLP architecture to CNN. So basically what I did here, it's the same import statements. And then, so this is for the generator. I did generator equals sequence. And then generator dot add a dense layer of 128 times 7 times 7 with input equals 100. Then I had to basically reshape this for upsampling. And then I did generator dot add upsampling 2D. I upsampled to 14 comma 14. Then generator dot add convo 2D transpose 128 kernel size equals 128 and kernel size equals 3. Basically just adding a conv layer. Next, I just did generator.add activation. Then generator, I had the upsample to 28 and 28. Then I just had generator.conv conv2d transpose 64 kernel size equals 3, same. It's basically the same, or almost the same command I had up here, except now we're doing using 64. Then I had generator, then I add another activation layer. Then I had generator.add conv2d 1 kernel size 3 padding equals same and activation equals TANH, which should give me an output shape of 28, 28, and 1. Next, I had the discriminator. So first I started with discriminator equals sequential. Then I have convolution layers to extract the features. So I have discriminator, add convolution 2D 32 kernel size equals 3, strides equals 2, and the input shape of 28, 28, and 1. Then I had added a layer for leaky Ryu, which alpha e just equals 0.2. Then discriminator.add dropout was 0.25. Then added a convolution 2D 64 kernel size 3 strides 2 and strides equals 2. And discriminator.add. Then I had just another one of these commands and then another dropout layer. Then I flattened use discriminator.add flatten just to have flatten it. And then to classify, I did discriminator.add dense 1 activation equals sigmoid. And it should output whether or not it's real or fake. And then I just compiled the discriminator. So discriminator.compile loss equals binary cross entropy using the atom optimizer. And for metrics accuracy. So the rest of the code should be the same as what was given. And then here, I just added a folder, added code so that it would create a folder that it could save all these different images to, all these different iterations of it. And as you see, after running the code, as you can see, so it starts out over here, real blurry. Then we get, as we do 400, as we cycle through 400 times, it starts to get more clear and clearer. And as we do 3,000 times, it gets even more clear. The example goes all the way up to 8,000, but here I've only gone up to about, I've only gone up to about 4,000, just this running time, because it takes so long to run, I don't have time for.